Find the limit as x approaches infinity of the square root of 2x squared plus 1 over 3x minus 5. Now this one is similar, but we have the radical this time. And we're supposed to multiply 1 over the highest power of x in the problem. Now, when you start seeing radicals, we're not allowed to take the square root of individual pieces of a radical. So let me just show you what I mean. If I have the square root of 4x squared plus 9, that does not equal 2x plus 3. We know that, right? We're all good with that? All right. So, knowing this is a fact, I just want to make sure you know that's a fact because I'm going to break the rules a little bit on this. But this is illegal. When you're searching for the highest power of x, look at each individual term in a radical and divide it by the root and to see what the power of x is in that specific term. So 2 divided by 2 is 1, so this is actually x to the first power right here. This is x to the 0 power, x to the first, x to the 0. So the highest power of x is x to the first power. All right? Again, when we're searching for the highest power of x, again, you can just individually look at pieces. Just the highest power of x inside the radical, take its power divided by the root. That's the actual power of x within that expression. All right? So 1 over x is the magic multiplier here. Now watch what happens here. On the bottom, I'm going to multiply by 1 over x. On top, I'm going to multiply by the square root of 1 over x squared. When you do that, you have to be cautious. Let me show you why you have to be cautious. In this case, we're letting x approach positive infinity. So x is representing some positive big number, right? 1 over some positive big number is positive, right? And 1 over some positive big number squared is positive. Take the square root, you get a positive. We all see that okay? If x happened to be approaching negative infinity, this is actually negative, right? Because again, x is approaching some negative big number. 1 over big number negative is a negative number. Square that negative number, you get a positive, and all of a sudden this thing up here is positive. Okay, so we have to do some sign changing in that situation. So when you do this, multiply top by a radical, bottom by not a radical, just to create structures that can be worked with, you have to ask yourself what type of sign would be on these. If they're the same sign, great, you're ready to go. If not, you have to modify them. Example 3 gets us to the modification problem, I think.
Yeah, it's negative.
Excellent. Okay, yeah. So we'll see how to deal with that in example 3. But anyway, once I get this structure, within the radical, we have a rule that says we can multiply inside radicals, radicand times radicand. So 2x squared times 1 over x squared makes 2. 1 times 1 over x squared makes 1 over x squared. On the bottom, 3x times 1 over x makes 3. Minus 5 times 1 over x makes minus 5 over x. We're still doing a limit as x is approaching infinity. Once I've done that, I've created a new structure that's the same expression, different structure. It creates nice, pretty numbers that don't have x's on them, which is what we want, along with a bunch of numbers over x's, which equals 0, right? So, as x approaches infinity, this goes to 0, and this goes to 0. Everything else sticks around. Square root of 2 left on top, 3 left on the bottom. That is your limit.